Let's talk refrigerators. A refrigerator is basically just a backwards heat pump. Work is done on the system to transfer heat from a cold reservoir to a hot reservoir. So instead of taking heat from a hot to cold reservoir and using it to do work, you put work in and move stuff from cold to hot. Okay? Now you'll say, okay, well, a heat engine does this thing over here, and a refrigerator does this. Why can't you connect them and get 100% efficiency? Well, it turns out that doesn't work. And this sort of explains it. So if this guy says, I don't have air conditioners, so I was thinking of just opening up my fridge to cool my apartment, what do you think? Do you think this is going to work? Okay? And the answer is obviously going to be no. But why doesn't this work? Well, what happens outside the back of your refrigerator? What happens to the heat that we take out of the refrigerator? Well, that's expelled into the room. Okay? So really, if you open your refrigerator, it'll cool the part inside the refrigerator a little bit, but the amount of heat that comes out of the refrigerator is always going to be bigger than the amount of heat that you pump out of it. So the net heat, the net temperature of the room is actually just going to go up. All right. So let's talk second law of thermodynamics. One statement of the second law of thermodynamics is there's no such thing as a perfect heat engine, because a perfect heat engine would violate the second law of thermodynamics. Okay? So no heat engine can ever convert heat completely into work. There's always some waste. There's always something in the QC. All right? So how do we